The lesson outcome for this video is, I can graph a parabola by finding the x-intercepts in vertex form. Now we've seen a lot of problems like this now already, and the way we've found our x-intercepts in the past has been by either factoring or using the quadratic formula. We'd fill those in, we'd find some other y values so that we could plot some more points, and we would draw our parabola on the coordinate plane. We're going to do the same thing here, but we are going to find our x-intercepts this time by undoing the PEMDAS steps. Please excuse my dear Aunt Sally, or in other words, parentheses, exponents, multiply, divide, add, and subtract. But again, we are going to be undoing the steps to solve. Okay, so to start this process, we need to first put 0 in for y. So we're going to go ahead and fill 0 in for y. And we get this equation here. And we are going to solve this again by undoing the PEMDAS steps. We're going to start by adding or subtracting. And again, there's all this stuff that's being done to the variable x. We need to undo it all, but we can't undo this minus 6 here by adding until we get to the parentheses stage. So the adding right now is this adding of 4. So we're going to add the 4 to both sides of the equal sign. And when we do that, we're going to get 0 plus 4, which is 4, equals 4 times x minus 6 squared. Now we are going to multiply or divide to undo, and in this case we're going to divide by 4, because 4 divided by 4 is 1 over 1, or just 1, and over here we have to divide by 4 as well, both sides of the equal sign. 4 divided by 4 is 1, so 1 equals x minus 6 squared. Now, x minus 6 is still stuck in the parentheses, and the next thing we need to do is deal with our exponent. Remember that undoing a squared situation is square rooting. So we will square root this side of the equal sign, which will cancel the squared and the square root, but we also have to square root the other side. It's very important to remind yourself that whenever you square root both sides of the equal sign, you will get a positive or negative answer for your square root. So the square root of 1 is 1, so positive or negative 1 equals x minus 6. We're now going to deal with that last step, which is our parentheses. Now from the very beginning, we had x minus 6, so that x minus 6 is the last thing we deal with, which means we need to add 6 to this side to cancel those, and we can add 6 here. Alright, so the negative 6 and the positive 6 right here will cancel out, because negative 6 plus 6 is 0. At this point we have x alone on one side of the equal sign, and I'm going to write then that x is equal to, we got to separate this into two different problems. So positive 1 plus 6, positive 1 plus 6, and then we have to deal with the other option, which is the negative 1 plus 6. So negative 1 plus 6. So x equals positive 1 plus 6, which is 7, or x equals negative 1 plus 6, which is 5. We have found our two x values, which are our x-intercepts because they are the values of x when y is 0. We're going to go ahead and put those in, 7 and 5. Okay, now we're going to go ahead and plot those two x-intercepts at 7, which is right here, and 5, which is right here. It's going to be a pretty narrow parabola here. All right, now remember that in order to graph this, we need some additional points. I'm just noticing now that the values I chose here were not the best, because we know right here the 5 is going to be 0, so we already know the 0 would go here, so we're not going to use this value. And we also know that the 7 is going to give us 0 too, so those two values aren't the best. Maybe we'll find some other values for x that will help us find y. So we can plot those points and graph the parabola. But for now, let's try the 4. Remember, we need to put a value in for x in the equation so that we can find the output for y. So I'll go ahead and do that up here. Y equals 4 times, in the parentheses is x minus 6, so that's going to be 4 minus 6 squared minus 4. And again, you can just type this into your calculator, being careful to use parentheses and the squared, and we are going to find that the y value is 12 if you do that accurately. Now that doesn't fit perfectly on the graph either, but we're going to go ahead and plot it. So 4, 12, again, that's a point right there, 4, 12. So 4, 12 would be right about here. Again, sorry, that's not quite on the graph paper, or the coordinate plane. And if we pick another value, let's say 8 down here, right, and put an 8 in instead of a 4, so we're going to give y equals 4 times 8 minus 6 squared minus 4, we are going to actually get 12 again when we do that. And a lot of times we'll get the same values for y because a parabola has two x values that have the same y value typically. So we're going to go to 8, 12, which is also up here, a little bit off the graph coordinate plane. Okay, and now I'm going to plot one more point in here. And the point I'm going to use, I should have put that in earlier, is we're going to find it for 6. So again, go ahead and now put a 6 in instead of a 4, and go ahead and find the corresponding y value. And what you're going to get when you put a 6 in is a -4. All right, so 6, -4 is the vertex. And if you think for a minute about why you know that, it would be a good question to ask yourself. How do you know that that is the vertex? Okay, hopefully you were thinking about the fact that we find the vertex by finding the middle value of these 2 points. So if you were to add 5 plus 7, which is 12, and divide by 2 to find the average, that's 6. So you know that 6 value is going to help us find the vertex. So there is our parabola. Try to make it look like a U and not a V. It's hard when they're narrow. And there is our graph.